In this video, we're going to explore the Poisson distribution. The Poisson distribution is different from the binomial distribution in several ways. The shape of the distribution is different, and the information that we are given is different. So in a Poisson distribution, we must have that each success is independent of other successes, and we must have the mean number of successes in a given interval remaining constant. So the values that we're going to be given or that we need to make sure that we know to find the solution is the mean number of successes in a given interval, denoted lambda, and then the x value, which represents the number of successes in the given interval that we are trying to test. So again, we're going to be using Excel for this. If we wanted to do this with our calculator, then you need to know where the E is. And E is an irrational number, kind of like pi. And it's a button on your calculator just like pi. It's about 1.7-ish. And typically on your calculator, you're going to find that it's near the natural log or possibly above the natural log button on your calculator because it is the natural log of E is in fact 1, which is why those two are related. So let's take a look at a question and then we'll look at the same question in Excel because Excel just makes everything easier. So let's say a barber usually finishes one haircut every 15 minutes. We want to calculate the probability that our barber is feeling extra speedy one day and finishes 6 haircuts in 1 hour. So things to look out for here. First of all, is each success independent of others? Well, yes, him being able to complete a haircut is independent of other haircuts. Do the mean number of successes in a given interval remain constant? Yes. One haircut every 15 minutes is constant. That's his average. So now let's take a look. And here's where students really struggle with the Poisson distribution. In this question, I'm given one haircut every 15 minutes, and then it asks me about 6 haircuts in 1 hour. So 1 hour is the interval in which I'm interested in. So the mean number of successes is not going to be 1 because it's one haircut every 15 minutes. I need to say, based on this, how many in 1 hour? And so if it's 1 every 15 minutes, then lambda is going to be 4. I can expect 4 in 1 hour given 1 every 15 minutes. And that's really the hardest part of this. And now the number of successes in the given interval, now that's where we go to the question. So x is going to be 6. So all I'm going to do is plug those values into my formula, and then I'm going to use my calculator to evaluate it. And I get about 0.1042, which means that the probability that he can finish 6 haircuts in 1 hour is about 10.42%. Let's take a look now at how to use Excel to calculate this for us. And again, I'm going to show you how to set this up so that you can continue to use the same cells over and over. But before we do that, let's just take a look. It is, of course, Poisson.dist. And again, notice that it says x mean cumulative. So x is the same x as before. How many are we testing? We're saying, can he perform 6 haircuts in 1 hour? The mean is how many we expect him to complete in 1 hour, which is 4. And cumulative is going to be false until we start looking at cumulative distributions. And notice I got 1.10419 and so on. And that's fantastic and the correct answer. So again, for a question on a project or a question on a forum, this is how I would set this up. If I'm working on my certifications, then I can certainly utilize Excel to not have to do quite as much work. So again, the number of successes was x, the mean or lambda was 4, and then I can say exactly x would be Poisson dist, and then the mean the x, and then the mean, and cumulative is 0 or false. And again, I can get the same answer that I found by hand, and this way it's just easier because I can just manipulate the x and the lambda values. Here are 2 questions for us to try, and if you're feeling confident, go ahead and try these questions on your own, and if you're not, just hang tight, we're going to go through them together. For the first, we say that the accounting office takes in an average of 3 new tax returns per day during tax season. What's the probability that on a given day during tax season, the firm will take on just 1 new tax return? So for this one, we don't have to do anything crazy to find the mean. We know that on average, there's 3 new tax returns per day. That's the mean. And we're testing in 1 day, the firm will take on 1 new tax return. And so again, now I have my solution, which is there is about a 14.9% chance that the tax office will take in only 1 new tax return. For my second distribution, or second question, the dial-up internet connection at your house goes out an average of 0.9 times every hour. That's super annoying. If you plan to be connected to the internet for 3 hours one afternoon, what's the probability that you will stay connected the entire time? Okay, this one's a little bit harder. So notice it says an average of 0.9 times every hour, but the question asks for over a 3-hour span of time. So the mean is 0.9 times, but it's every hour, so it's over 3 hours, which means 2.7 times I would expect over the course of 3 hours. Now, what's the number I am testing? Well, the question says the probability that you'll stay connected the entire time, which means what's the probability that I don't ever lose access? And let me just make sure I have this set up right, and I do. And so it's about 6.7% probability, which is not great, that I will be connected the entire time. Here's another question for us to try, and now we're going to look at cumulative Poisson distributions. And so again, cumulative just means that Excel is going to calculate from the number that you enter for x, from that value all the way down to 1, so to the left. Now, just as we did with the binomial distribution, you can sort of hack Excel to make it work for you. So let's talk about those equations. Exactly x, again, is exactly what we just did. The x value, the lambda value, and 0 for cumulative. If I want less than, that's Poisson dist, I'm going to take 1 away from the x value because I don't want to include the value that I'm given. I want to go only less than that. At most, which is the same as less than or equal to, at least, which is greater than, and more than, I'm sorry, at least is greater than or equal to, I apologize, greater than or equal to, and then more than is greater than. And of course, this is just less than. So again, I can do the exact same thing I did with Excel with the binomial distribution. I'm simply replacing it with the Poisson distribution. So for less than, I'm taking 1 away from x and going to the left. For less than or equal to, I'm using the exact value that I'm given. For at least, which is greater than or equal to, I'm taking 1 minus, and then I'm taking 1 away from x. And for more than, I'm taking 1 minus, but I'm using the exact x value. So let's take a look at this question. A math professor averages grading 20 exams per hour. What's the probability that she grades more than 35 of her 60 statistics exams during her uninterrupted hour and a half between classes? So again, a little bit more going on here. The average, the mean that we could expect this math professor to grade is 20 per hour, but we're looking at an hour and a half. We're looking at 90 minutes. So the mean is 20 times 1.5 because it's an hour and a half, which is 30. The number of successes, the question says that she grades more than 35. So there's the 35, that's X. And again, our solution would then be more than 35. And that's all we would have to do. Again, for a project or for a forum, I would want to see you type out this actual function and not use these extra spaces. This last question is for you to try on your own. So if you would, press pause, try this question, and then when you're done, press play to see how you did. So we have a typist averaging 4 errors per paragraph if he is typing a 5-paragraph document. So let's stop right there. 4 per paragraph and 5-paragraph document. So how many errors do we expect this typist to make? Well, 4 times 5 would be our lambda. So you can either just type in 20 or you can type 4 times 5. If he is typing a 5-paragraph document, what's the probability that he will make fewer than 10 mistakes? So if I put 10 here, it's going to take 10 or fewer, which is why we're going to use this value, less than, which means we're taking 9 or less. So again, if I were doing this for a forum post, I would take not 1 minus, we're going to the left. So I'm going to say Poisson dist, if I can type. X would be not 10, but 9. So 9, comma, the mean is 20, cumulative is true. And that would be my solution. And again, it's the same solution here in less than, but you need to know which one is which. Up next, we're going to finish up Chapter 5 by looking at the hypergeometric distribution.